Alright, so today we're going to talk about Gauss-Jordan elimination. And really the thing you need to get from this lesson is when we continue applying elementary row operations, so by applying, or by continuing, to apply to the row echelon form of an augmented matrix, you can write the matrix in reduced row echelon form. And reduced row echelon form is going to give you a matrix where in the first row you're going to have 1 followed by 2 zeros, or as many zeros as you have variables, and then a value. We'll call that A. And then a 0, 1, 0, followed by a B. And it's going to be a triangle identity followed by a value. The solution to this is just going to be that you'll have x equals A, y equals B, and z is equal to C. That's really all you need to know about putting it into reduced row echelon form, or Gauss-Jordan elimination, which is named after, again, Carl Friedrich Gauss, that we talked about with the Gauss elimination, but also Wilhelm Jordan, both German mathematicians. So now let's look at an example. Our first example, we are going to solve by using Gauss-Jordan elimination. So our system is going to be x plus y plus, minus z is equal to -6, 2x minus y plus z is equal to -3, and -x minus 5y minus 3z is equal to -14. So we're going to start by writing this as an augmented matrix. So we can write this as 1, 1, -1, -6 for our first row, 2, -1, 1, -3, and then -1, -5, -3, -14. All right, so when I'm looking at this, I think what I want to do first, and my work might go on to multiple pages here, is take my second row and subtract 2 times my first row from it to get a new second row. So I'm going to go 2, -1, 1, -3, and I'm going to subtract from that 2 times my first row. So I'm going to subtract from it 2, 2, -2, -12. So from that, I'm going to get 0, -3, 3, and 9. So now my matrix is going to look like 1, 1, -1, -6, 0, -3, 3, 9, -1, -5, -3, -14. And I'm now going to take my second row, I'm going to do another operation to it. I'm going to just divide it by -3. Pretty simple one. And then get a new second row from it. So my first row is going to stay the same, 1, 1, negative 1, negative 6. My second row is now going to be 0, 1, negative 3. If I divide everything by 3, negative 3 there. And then negative 1, negative 5, negative 3, negative 14, to just create an equivalent matrix. Now I'm going to start in on my third row. I'm going to take my third row and subtract from it add to it my first row and get a new third row. So I'm going to go, and I'm just going to use the space up here in the top right corner. I'm going to go negative 1, negative 5, negative 3, negative 14, plus 1, 1, negative 6. I'm going to end up with a 0, a negative 4, another negative 4, and a negative 20. So my new equivalent matrix, 1, 1, negative 6, 0, 1, negative 3, and 0, negative 4, negative 20. So I've run out of space, so I'm going to just rewrite this new matrix on a new screen so we can continue with our operations. And you could do whatever you want moving forward with this, but what I'm thinking I'm going to do to create another equivalent matrix is I'm going to take R3 and just divide it by negative 4. By doing that, my new matrix will be 1, 1, negative 6, 0, 1, negative 3, 0, 1, 1, 5. So we're almost in row echelon form. What I'm going to do next, I'm now going to go R3, row 3, minus the second row to give me a new third row. So I'm going to go 0, 1, 1, 5 minus 0, 1, negative 3. So I'm going to have 0, 0, 2, 8. So my new matrix is going to be 1, 1, negative 6, 0, 1, negative 3, and 0, 0, 2, 8. I have one more step to get into row echelon form. I'm going to take my third row and just divide by 2. So now my matrix is 1, 1, negative 6, 0, 1, negative 3, and 0, 0, 1, 4. So we've got row echelon form. We want to get reduced row echelon form, which means in that first row, we want to get the 1 and the negative 1 to a 0, and in the second row, we want to get that negative 1 to a 0. So moving forward, what I'm going to do next is I'm going to take my second row and add it to my third row to get a new second row. We can do that. So I'm going to go 0, 1, negative 3, 0, 0, 1, 4. And I'm going to add these. So I'm going to get a 0, I'm going to get a 1, negative 1 plus 1 is 0, and negative 3 plus 4 is 1. So our new matrix is going to be 1, 1, negative 6, and our new second row is 0, 1, 0, 1, and our third row is still 0, 0, 1, 4. So we're almost done. We've got 2 of our solutions. I believe what I'm going to do next is I'm going to take my first row And I'm going to add to that my third row to get a new first row. So I'm going to go 1, 1, negative 1, negative 6. I'm going to add to it 0, 0, 1, 4. So we're going to end up with 1, 1, 0, negative 2 for a new first row. So we're not quite in reduced row echelon form, but almost. We're going to have 1, 1, 0, negative 2, and 0, 1, 0, 1, and 0, 0, 1, 4. So let's do one more row operation. I'm going to take my R1 and subtract R2 from it to get a new R1. So I'm going to go 1, 1, 0, negative 2 minus 0, 1, 0, 1, which will result in a 1, 0, 1, and a negative 3. So our new matrix, our final matrix, in fact, I actually put one thing wrong here. It should be 1, 0, 0, negative 3. It's going to be 1, 0, 0, negative 3 for our first row, 0, 1, 0, 1, and 0, 0, 1, 4, which means our solution, we're done with this now. Our solution is going to be the ordered triple, negative 3, 1, 4. That's a lot of work. And for that amount of work, we're going to skip the next few examples. And in class, I'm going to have you follow the directions on your note sheet on how to use a graphing calculator to do this process. But the last thing I want to include in this video are some special cases, some special solutions when using reduced row echelon form. So, we've learned in previous lessons that not all systems are going to have a unique solution. So, here are some ways that you can help determine if you have a unique solution, no solution, or infinite solutions. If you are going through and putting your matrix into reduced row echelon form, and you get a matrix in the form 1, 0, 0, a value, 0, 1, 0, another value, and 0, 0, 1, and a third value, in this case, you're going to have one solution. And that solution is going to be the three values as in order to triple. If you're going through reducing the matrix to get it into reduced row echelon form, and you have something that is like 1, 0, and maybe a value like 2, 0, 0, 1, negative 2, 0, and then you have a row with 3 zeros followed by a value, you are going to have no solution. In fact, we can generalize this and say if you have any row that contains 3 zeros, then a number, that's when you'll have no solution. And if you have a case, maybe you get a matrix that looks like 1, 0, 2, 2, 0, 1, 0, 3, and then 0, 0, 0, 0, you're going to have infinite solutions, or infinitely many solutions. We say this happens when we have a row with all zeros. All right, and then with our final examples, they're all using a calculator. We'll go over those in class. You can follow the directions in your note packet, and we'll go over the solutions together.